In today's lesson, we're going to determine if a quadratic polynomial is factorable or if it's prime. If it is factorable, then we're going to factor it. So let's take a look at our very first example, 4x squared minus 5x minus 12. In order to determine if something is factorable, instead of doing the entire quadratic equation, we're just going to calculate the discriminant, or b squared minus 4ac. So in this particular example, my discriminant is going to be b squared, or negative 5 squared, minus 4 times my a also happens to be 4, and my c is negative 12. All of this equals 25 minus 96, which is actually negative 71. I don't even really care that the answer is negative 71. I just know that this is giving me a negative number. And if it's giving me a negative number, that really means in the quadratic formula, I have something and then plus or minus the square root of a negative number. And since I can't take the square root of a negative number, then I know that this cannot be factorable. If it cannot be factorable, in this particular instance, we know two things. We know that we have no real solutions, and we also know that this is prime. Prime means that it cannot be factorable. If we take a look at our second example, I want to do the same thing, the discriminant. In this case, I'm going to take negative 5 squared minus 4 times my a, which is 3, times my c value, which is negative 2. This is going to give me 25. Minus times a negative is going to give me a positive. 4 times 3 times 2 is 24. This equals 49. Now 49 is a positive number. If it's a positive number, that means I'm going to have two real solutions. But this also is asking me if I can factor it. If I get a perfect square like this, 49 is a perfect square, then my answer is that it is factorable. Okay? And I know that it's factorable because this is a perfect square. So then I do need to factor. And if I come back up to this and I factor, there's a variety of ways that you could use the guess and check method or grouping. You'll find that the factors are 3x plus 1 times x minus 2. So the things that we're looking for in summary are to calculate the discriminant. If it gives me a negative number, I know that it's prime. If it gives me a positive number, I know that it has two real solutions, but I'm looking to determine if it's factorable, and it will only be factorable if my discriminant equals a perfect square.